the same thing. I
Never practiced.
I didn't do it in the middle school.
It sounded cool at the time to say that I played the drum. I didn't actually play the drum.
I feel like everything looked cool back then. Like when they were like first saying, "Let's get in the band," I was like, "Oh my gosh, this is so cool."
This is why I didn't read it to my son.
Like this is the new hip thing to do, but it was not.
All right. So I am leaving some blanks here to complete the square. So I reordered my x's, I reordered my y's, and then my blanks are for my perfect squares. My first perfect square would be half of 16, because you're distributing that 16 evenly, and then squaring it. So it would be 64. And then half of -6, that's the -3, and then you're squaring it. 9. All right, so those are like my numbers I'm adding in. I just have to make sure I do it to both sides. So it's half the middle number squares. It should always be even because when you square any number, it ends up even.
I'm sorry, since that 48 is positive, that's why you have a negative?
Yeah, because I had to move it to the other side. So I subtracted it. I just skipped that step where I did -48. From here I would factor, so what multiplies to 64 and adds to 16? +8 and +8, so +8 squared. What multiplies to 9 and adds to -6? -3 and -3, or -3 squared. My guess is when I add all of those together, I get like 36 or 25. So one of them, it's usually a perfect square. 36, 25. Which one?
25.
25, thanks. All right, 25. I didn't want to actually have to do the math myself. All right, we okay with that?
Or like the parenthesis parts, like that number you find, you say it's just half of B.
Always half of that. And
You
if
have
B is
to-
positive, this should be a plus.
Yeah.
And if it's minus, this should be a minus. And then I'm just dividing that by 2. Because I want to like split it evenly. Every time, the same process. All right, center is an x comma y. But remember, if you're in parentheses, you're going opposite of that. So the +8 is going to turn to a -8. And the -3 is going to turn to a +3. So that's my center. It's at -8, +3. And then this number right here is my radius squared.
But
25 is a really big radius. That'd be a really big circle. It wouldn't fit, right? So we want to do the square root of 25, which is 5, which is going to send us in 5 in every direction. So we'll go 1, 2, 3, 4, 5 left, 1, 2, 3, 4, 5 right, 1, 2, 3, 4, 5 up, 1, 2, 3, 4, 5 down. And then you'll just do your best to make it look like a circle. That was all right. Okay. So that's what we did yesterday, and then Monday we did complete the square. Today we're going to learn about parabolas. You know a little bit about parabolas, so I'm going to try to like focus in on your past knowledge to use what you know to help you learn some new stuff, okay? So, let's see what you know. Tell me what you know about a parabola. Like, what's it look like? When I say the word parabola, what are you picturing?
N or U.
A U. All right, so we've got a U or a U, right? Okay.
McDonald's.
What else?
McDonald's, the big arch.
The M, the double M. Okay, all right.
Big arch.
Max and mins. Are they absolute or local? All right, we've got absolute, max, or min, which, if you have an absolute max or min, it means that it's, I'm thinking of a B word, bounded. Okay, we know some stuff.
They're symmetrical, so there's an axis.
Symmetrical is very important. There is an axis of symmetry. Symmetrical, maybe I spelled that right. I don't know.
Like sideways like that.
It sure can. that's what we're gonna do today. So you're gonna have that same shape that way. But you might not know that, right? That might not necessarily be past knowledge for everybody. We'll save that one for later. What about like an equation of a parabola? What does every parabola's equation have to have? Like what makes the U?
The x squared.
X squared, right? So this is x squared. So what's that?
Negative x squared.
Negative x squared. Okay, good. All right, this is good stuff. All right, so we are going to use this knowledge, and we're going to start to graph parabolas today. We're going to graph parabolas without a calculator. I'm not taking your calculator away from you. Okay, so like if you need it to do some like mental math type stuff, you're going to be able to use it. But I'm going to show you how to get like a sketch of a parabola accurately without having to go to the table in your calculator anyway. All right, so if I have x squared, we just talked about what they look like. So what we're going to do is this. So Will just told me that x squared is a u, and that negative x squared is an upside down u. And Aiden kind of already touched on this. What do you think y squared would look like?
Sideways.
Sideways, right? Which way do you think the positive one would open versus the negative one?
The positive.
The positive one's going to look like a C, kind of. It's going to open towards the positive direction, and the negative one's going to look like this. So we're already like halfway there in terms of this is what a parabola looks like. What you're going to learn is like how do you make it wider and skinnier without using the calculator? Like how do you accurately know how wide it is? How do you know where it falls on the ground?
Would those be bounded, unbounded?
These would, yes, well, now we could say like bounded left, bounded right, yeah. Yep, so there will be boundedness, it'll just look different. All right, so, not to overwhelm you here, but let's think this. If x squared looks like this, all I did here was take my y and like do a minus something, and take my x and do a minus something. What do you think that does to the equation? Well, in a circle, that's my center, right? Like HK. So in a parabola, it's called your vertex, still your center. And what the HK does is it just moves it. So it's going to take that same U shape and maybe put it like there. It's just shifting it. So like it might shift it, if this was like a 2, right 2, up 5, right? So if this is negative x squared, the negative's still there, the x squared is still there. All I'm doing is adding some sort of shift to the y and the x, which might move it somewhere else on the graph. Same idea here. If this is y squared, we said it opens positive. All I'm doing is shifting the x and the y, which might move it somewhere else on the graph. It's still that same shape. Make sense? And then if this is the negative y squared, then the k and the h might move it somewhere else. It just depends on what the h and the k are. And to get the h and the k, that's the same way you get it from a circle, right? You're going to look at the parentheses, and you're going to do what's opposite. So like this point here would be the positive h and the positive k. All right? So basically, this is the standard form of a parabola. We're going to add one more thing in. So on your toolkit on page 3, you'll see these two formulas. And just a reminder, I told you this yesterday, you do not ever have to memorize the formulas. So on your quiz on Friday, at the very top of the quiz will be the circle formula and the parabola formula. You don't have to know that, okay? It's going to be there for you. You just have to know how to use it. So basically everything we just talked about is here except this thing 4p. That's new. The 4p is what's going to make the graph skinnier and wider. It's kind of like a slope, if you will, right? Making the graph fatter and skinnier. So we'll talk about what that means specifically when we get to an equation. But for your actual toolkit notes, I just want you to jot this down. If you have a parabola that looks like this, here is how I know it's a parabola. one term is squared and the other term is not. In a circle, if you think about back to the warm-up, they were both squared, right? We had an x squared plus y squared, and we completed the square twice. So a parabola is the only one of the 4 shapes you'll learn that only has one squared term. So it stands out pretty easily, all right? So I know it's a parabola because it's got one squared term. And I'm gonna have this visual of what it looks like, because in this one, the only squared term is x, right? X is the one that's squared, y isn't. And there's gonna be 2 types. I'm gonna have x squared on this side, which is gonna make it either a u, right? Because you remember from last year, last unit, that if you have an x squared, it's a u shape. And then if you have a negative x squared, it's an upside down u, right? And how you'll know in this formula which one it is gonna be based on, see how that has like a plus minus in front of it? If you have a plus 4p, then it'll be a u, whereas if you have a minus 4p, it'll be an upside down u. So that number on the other side is gonna determine the direction. So the shape, u or upside down u, is coming from the fact that x is squared. And the direction, up or down, is coming from this coefficient over here. If this coefficient's positive, you're gonna be looking at an up. And if this coefficient's negative, you're gonna be looking at it down. And it's not gonna have a p, it's gonna be like a number. So it might be like a negative 12, right? So if it's negative, it'll go down. Whereas here, on this side, I'm noticing that the squared term is y. The x doesn't have a squared with it. I know it's a parabola because a parabola is the only shape that's going to have one squared term. And if it's y that's squared, y squared is not your traditional parabola, right? When I go into my calculator, the traditional parabola is x squared. So I know that's these ones. That's what we're used to seeing. So the y squared is going to be what you're not as used to seeing, which is a sideways parabola, like your C or your backwards C. And this one is called opening to the right because the open side is facing the right. It's opening in the positive direction. So you're going to have this one when you have that positive coefficient, versus opening left is going to go in the negative direction. That's when you're going to have a negative coefficient. And the P won't be there, it'll be a number. Right? You don't have to memorize the formula, but you will have to decide which way it opens based on the formula. So you're focusing on 2 things. Which value is squared, and is there a positive or negative coefficient? All right, so I think there's a spot for you to take some notes on these words, right? So the first definition is vertex. It's basically the same thing as a center. It's just not called a center because it's not like a circle where there's things around it. So we switch the word to vertex, but it's your HK, just like the center of your circle is. And it's opposite of what's with X, opposite of what's with Y. Focus is a new vocabulary word. So it's a coordinate point that's P units from the vertex, which hopefully makes sense when you see an example, all right? So, but here's what you need to know. The focus is a coordinate point. So when you have a blank that says focus, in that blank you're writing a coordinate point, X, comma, Y. And it's just going to depend on what this P value is, what we're going to write for it. The directrix is going to be either an x equals equation or a y equals equation. Depends on the problem. Depends on which way the graph opens. It's going to be p units in the other direction. So if the focus is to the left, the directrix is to the right. If the focus is up, the directrix is down. They're in opposite places. The focal length is this letter P that I'm talking about. When I think of focal length, I'm thinking radius. It's very similar to a radius. You know how with the circle we went left 5, right 5, up 5, down 5. A radius is all directions, and that's why I'm not giving it the letter R. Because a P only goes left, right, or up, down. It doesn't go all 4. So it's not truly a radius, but it does the same work as a radius does. It just only does it in 2 directions rather than 4. And then the focal width is 4P. So I tried to put all of the things that involve this P in green so you can see like they're linked. And I'll show you what they mean on the graphs I have sketched up here. All right, so I'm going to move this down. So on this graph up here, my vertex is the actual point where like the minimum or maximum happens. I think Max, you said something about like symmetry. It's like the point of symmetry, right? It's the very middle of the graph. So you can see on the sketches I did, the vertex is right in the middle. It's the turning point for all of them. And I think you'll find that that one's really easy to find in an equation. It's just opposite of what's with x, opposite of what's with y. Now your focus, if you notice the green point on all my graphs, do you see how the green point is inside of all of the parabolas? Okay, your focus is always inside of the actual shape. So depending on which way it opens, where the focus goes is going to change, right? You can see from my center here, the focus was up. But here from the center, the focus was down. And here from the center, the focus was right. And here from the center, the focus was left. And all of those things is the way that the graph was opening. So the focus always goes towards the opening. And what it is this length right here is your P, whatever that may be. You'll get that from the equation. It's your radius. So your distance from the center to this point is called P. Right? It could look differently in terms of direction, but like the distance itself. There's also a distance from the center to the orange line, which is called directrix. That's also P, right? They're the same distance apart. So this is P too. So the vertex is the center because you've got units going this way and this way of the same length. The other thing that's here is called a focal width. What that is at this point of the focus, it's going to create 2 points wide to see how wide the graph is. So that is 4P, right? How wide it opens. So at this point, I'll create 2 more points side by side. That's your 4P. So these things all work together and they create this shape. All right, so let's look at it with actual numbers and that might make more sense. All right, so on your paper, on the first page that you're at, there's A and B, and then the next page there's C and D. We're going to do like pieces at a time. So I'm doing what I think that you'll be able to do right away without me having to teach you. All right, so for this first one, I think that you'd be able to get the vertex pretty easily. Anybody think they know what the vertex of that A is?
5, -1.
5, -1. So opposite of what's with X, opposite of what's with Y. Just like you did for the circle. Easy enough? All right, now let's think which way it opens. Think about which is squared. In this one, the X is squared. X squared is your traditional parabola. It's the parabola that you have pictured in your brain, right? And X squared is one of these. So it's going to be, when I say opens, I'm looking for an up or a down when X is squared. This number 8 is called my coefficient. See how that 8's positive? That's telling me that this graph's going to open in the positive direction. So with words like up and down, the positive direction would be the up one. So this is a parabola that's going to open up. Does that make sense? I'm looking at what's squared and if the coefficient's positive. So when I eventually go to sketch this one, it's going to look like that. Obviously, on our actual graph, it will be a lot more accurate, but the general shape is gonna look like that. All right, let's look at this one, B. It's a little trickier with the vertex only because your vertex has to be x comma y, and y comes first, so just pay attention to that. My vertex for this one is gonna be opposite of what's with x, opposite of what's with y, which is in opposite order. So just be careful. Sometimes a common mistake would be 3, 2, because you just see it in that order. But x has got to, or sorry, 2, 3, but x has to come first. Now let's think about which way it opens. In this one, the y is squared. Y squared is not your traditional parabola, right? Like we don't go to the calculator and type in y squared ever. So these are your left and your rights, like a C and a backward C. This coefficient is positive, which means it's going to open in the positive direction. So if I'm thinking of the words left and right, which one's the positive direction?
Right.
The right, the C. So this one, eventually when we graph it, is going to have the general shape of that, like a C, opening sideways in the positive direction. All right, flip to the next page. Let's look at C and D. That's these two examples. My vertex is going to be opposite of x, comma, opposite of y. So -8, -4. The x is on the other side. This is a y squared parabola. Y squared, left and right. The coefficient is negative, which is telling me this is opening in the negative direction. So it's going to look really similar to B, but go the opposite way. We okay with that? All right, and then what do you think the center is for D? 3, -1. It's an x squared parabola, so that's your u and upside down u. Coefficient is negative, so where's it going to open? Down. So when you picture this one at the very end, it's going to look something like that. So half the battle is understanding that part. We okay with that? All right. So here's what we knew about A. Here's what we have to find. There's 2 more blanks, I think, or 3 more blanks, right? Focal length, focal width, and focus. All right? Those things are coming from this letter P that we wrote about in our notes. So, in a general formula for a parabola, it's x minus h squared equals 4p y minus k. So you'll see that in this standard form, in this 4p spot in front of the parentheses is now an 8, right? So the 4p came out and the 8 went in. You with me so far? So I can create this equation. 4p became an 8. All right? So what did p have to be? 2, right? If I divide both sides by... So my radius, and I'm using air quotes because it's not truly a radius. We're not going left 2, right 2, up 2, down 2. But we are going to go in 2 directions, 2. My radius is 2. Now the word for that is called the focal length. So the focal length is this p value. The focal width is 4p. You don't have to solve for the focal width. You could take your p and you could multiply it by 4, but the focal width is always just the one that's the coefficient, right? In this case, that's the 8. Or you solve for p, you could multiply it by 4, and you could get the 8 that way too, right? But the focal width is the one that's directly in the equation. All right, so let's look at example B. I'm leaving the focus out right now. I didn't fill in focus or directrix, I think, right? Those are 2 blanks. I think those are a lot easier to do visually with the graph, but let's just get the basics out of the way. All right, so if I'm looking at this equation, I notice that the y is squared. So in a traditional y squared parabola, which you don't have to memorize this formula, you'll have it. I'll notice that in this spot in the formula where there once was a 4p, there's now a 12. And what I need to do is figure out how that could have happened, right? So I'm going to take 4p and I'm going to set it equal to 12 to figure out, well, what did p have to be to make the 12 go there? 3. So p is 3. P is called the focal length. And 4p is called the focal width. So if this is 3 times 4 is 12. Everybody okay with that? All right, let's go to C and D. So flip the page. Same idea. What I'm noticing is y is first. So in a traditional y squared parabola, I've got this formula. And I'm just replacing all the letters with numbers, but this 4p is now a negative 4. I lost my pen. So what does p have to be? Negative 1. Now when I go to write it, you can write negative 1. But think about like focal length. When you're taking out, like, let's say a ruler to measure something, are you ever going to say negative 1 units, right? Like in terms of a length. How tall is that desk? You're not going to say negative 1 units. So the negative gives direction. When I see the negative with the p, it's telling me that this graph is either going to go left or down. The length itself, though, is 1. I don't care if you write negative 1 as the focal length, but technically the focal length is just 1. So I'm taking 4p and I'm actually just setting it equal to 4. The negative just helps me with the direction of the parabola. So p is 1. The focal width, again, a width doesn't make sense to be negative either. So I'm disregarding the negative in terms of that too. So this would be p and this would be 4p. Which would be 4. Make sense? It's not the end of the world if you put a negative there. It really isn't. But technically the negative just handles direction.
Do you do bottom 4p every time? Or?
Every time.
Okay.
That's just part of the formula. It's always 4. Yep. And I think for this last one we're going to get a decimal, but that's okay. So in this last formula, because it's an x squared parabola, you're looking at this one. In terms of its standard form. And so when I'm trying to find that p value, I'm going to do 14 equals 4p. Not negative 14, the negative is for the direction part. So if I divide both sides by 4, I get 14 over 4, so 3.5. Is my p-value. And 4 times that p is 14. That's my width. Okay, not including the negatives for direction. Everybody okay with those pieces? All right, now that you have all of those pieces, you can put them together and get the actual parabola. All right, so here's what we've got. You should have all of that part filled in, right, for your f. So here's how we graph it. 5, negative 1 is a coordinate point. So I'm going to go 5, negative 1. Here's that coordinate point. That's called my vertex. It's a point on the graph. This graph is going to open up. If you think back to the picture that I had for my notes, I can't go back in terms of them because it's not going to be there. My thing just deleted. But every single focus, that green dot was always inside. So the focus for this one has to be somewhere in here, which is what direction from the vertex? Up. Okay, so when I go to graph this focus, I'm going to want to go up. I want this to be gone. Okay. All right, so I'm going to want to go up. How many units up is my radius, right? Is my focal length. To create the focus, we want to use a focal length. The direction is going to be the same way the graph goes. So if my vertex is here and my focus needs to be here, I need to go up. How much do I need to go up? My focal length is 2. So from my vertex, I'm going to go up 2 and I'm going to make a point. That point is called the focus. And it's a coordinate point. So I can list the value of that coordinate point. It looks like it's at 5, 1. We okay so far?
Ooh, how'd you know to go up to? Because of the focal length?
The focal length. Yep, the focus is the focal length away from the center. The direction of where you make that point, left, right, up, down, depends on the way the graph's going to go. Because this one went up, that's why I went up. Sometimes you might go left, right? So it just depends on what it is. All right, so before I go to the directrix, there's another word that involves the focus that I didn't do anything with. Okay, so I graphed the focus, I used the length, but I didn't use the width. So the focal width is how wide the parabola is. You said earlier that it's symmetrical, right? So if I need it to be 8 wide, I need to make sure it's symmetrical 8 wide, meaning I need to go a certain amount this direction and a certain amount this direction, and that amount needs to be the same. So I need to take that 8 and I need to split it equally. You with me so far? If I split 8 equally, it's 4, yes? So from my focus, my focal width is 8 units wide. So I'm going to go 1, 2, 3, 4 this way, and 1, 2, 3, 4 this way, so that this distance is 8. And it's called a focal width because, look, it's the width at the focus. That's how wide the graph goes. So this is my focal length of 2. Sorry, not that one. This is my focal length of 2. So from the center to the focus is 2 units. And then the focus itself is 8 units wide. I need to make sure those 8 units are spread perfectly because it needs to be symmetrical. From here, you actually can graph you can actually graph the parabola now. So the parabola itself goes through the outside points. Remember, the focus was always just a dot in the middle. It didn't go through the graph. So this graph goes that way and that way. I knew it was going to open up, so it's still opening up. Now I know exactly what points it goes through width-wise. I needed to plot that focus because I wouldn't have gotten these without it. Right? So there's a necessity to it, but it's not actually part of the graph. The only part that you can't really find a necessity, and Miss Rousseau and I teach this course, and I've taught it for a lot of years. I've looked it up. I'm like, how can I explain to kids the relevance of a directrix? It's like part of the definition of a parabola in the textbook. But in terms of the graph itself, it really doesn't have any relevance. Okay? But it's part of it. It's part of the standard definition. So that's why I do it last. So a directrix goes in the opposite direction that a focus does. So if the focus goes up, then the directrix goes down. It goes down the same amount of units as the focus goes up. I'm still using that P. Remember I said P is kind of like a radius? So from the center, I'm going to go up 2, and I've got to go down 2 as well. So this is P, and this is P. But a directrix, if you look at your notes, is not a point, it's a line. And it's not a line that goes through the graph. That's called the axis of symmetry. Like if I drew this, that's the point of symmetry. A directrix goes the other way. It helps with boundedness, if you will, so like it goes below. So this is what the directrix actually looks like. It's this imaginary dotted line that serves as like a boundary to the graph. Like your graph is never going to cross this line. And since this line for this one is horizontal, a horizontal line is a y equals equation. And this y equals equation is crossing at -3 on the y-axis. So it's y equals -3. As you can see, it doesn't really have much relevance to your graph. But mathematically, it is part of it. So that's why I'm teaching it. All right, let's look at B. We already have part of B filled out, right? We've got the center, which was 3, 2. The vertex. We decided it was going to open right, which means it's going to look something like that. We decided that because of what's squared, and then we got a positive coefficient. We figured out that the p-value was 3 and that 4p was 12. Since we decided that the graph is going to open right, the focus is going to be somewhere inside of it, which means in relationship to the vertex, the focus is going to be on the right. If the graph opens right, the focus is right. So I'm going to go in the right direction. And since it's a focus, I'm going to go right the focal length, which is 3. So from the center, I'm going right 3, and that's where I'm going to land for the focus. So 1, 2, 3. This point right here is the focus. And the coordinate of that is 6, 2. At the focus, I'll also need a width. Now, the y part of this parabola is top bottom, right? So if I want to make this open, I'm going to need these points to figure that out. This whole distance right here is going to be 12. So what we're going to do is we're going to split it up evenly into 6 and 6. So from that focus point, I'm going to go 6 up and 6 down. Whereas with the other one, we went left and right. So that if I were to count all of the boxes between the top focus and the bottom focus, that's 12 total blocks. And then that's the parabola. So the parabola itself goes through the vertex and the focal width. The focus is always inside of it. The last thing that we do is called the directrix. If the focus is right, then the directrix is left. So from the center, from the vertex, I'm going to go left 3. So this is 3. I need 3 over here too. I'm not going to go this way. Your directrix doesn't go through your graph. This would go through my graph. So I'm going to go this way instead when I connect this. And an up and down line is an x equals line. And this is going through 0. You guys okay with that? All right, I'm going to have you, we're going to finish here with you trying C and D. And then before you head out, I'll just make sure that we have the graph on the paper. But see what you can do with C and D, knowing what we did. And then right before the end of class, I'll post some solutions for that. Sure.
For this one, I did the focus, but it says right 30, 31 cents.
So we went how many units? Your center's here, and you went 3.5 to the right, but you
Oh,
wanna
it's
go
there.
down. But you'll estimate, so let's count 3.5 down, so. 1, 2, 3, 4, 5, is that about, is it negative 4.5? Right, because you'll be in between 4 and 5. The line does not fit. This one goes off grid, huh? If I want it to be 7 and 7.
What do you mean now?
Wait, Miss Diamond, you're plotting the wrong vertex.
Yeah.
It should be 3 negative.
That's why. Thank you.
Because mine is on the graph.
I think I must have, is this the previous vertex?
That's A.
I must have copied and pasted, because I didn't change this either.
Yeah, that's A.
Alright, thanks. For not making me finish that whole thing.
And then your focus will be 3 instead of 5.
Go down 3.5. 1, 2, 3. Okay, that's better. All right. So here's what I got for this one. Because we decided that it was going to open left, I knew my focus had to be left, right? Because it's got to be inside of the shape. So I went left 1, which landed at -9, -4. It changed the x value. And then it needed to be 4 open. So I went 2 up and 2 down to make that full open width be 4. And then I connected it. The focal width isn't a coordinate point, right? I just need to create coordinate points from it. And then for the directrix, because my focus went left 1, my directrix goes right 1. And I don't want it to go through my graph, so I had to go up and down. And up and down is an x equals line. So that was x equals -7. We okay with that one? All right, the next one I just screwed up because I guess I was copy and pasting. Or I switched it since. All right, so +3, opposite of x, -1 puts me here. We decided it was going to open down, so I knew the vertex also had to be down. I went down 3.5, 1, 2, 3.5, and that was at -4.5. So the x value of 3, the y value of -4.5. I knew that from the focus, my width, my opening had to be 14, so I went 7 this way and 7 that way to create that width of 14. And that's why this one's wider. And then if my focus is down, then my directrix is up. So from my center, I went up 3.5. The directrix doesn't go through the graph, so it had to go this way. This is a y equals equation, and it's at 2.5. What do you guys think? Fine? Hard? Remember, you don't have to memorize the equation, right? So you'll have that. Tomorrow, I have a half day in the morning and half days end at 11. So I'll be here for half your class, just not the first half. Okay, so you'll have to stop for the first half. So what you're doing tomorrow is on the backboard. You're just going to do some practice with parabolas before I come in. And then what I'll show you at the end of class is how to complete the square with a parabola, which really isn't much different than what you already know how to do. We just want to manipulate the equation to look like a parabola equation instead of a circle. So I'll show you how to do that. And then, like I told you, I have you all in my bonus block for Friday for a practice quiz, and then Friday is your actual quiz on circles and parabolas. Okay? All right, there is a Canvas assignment posted. As always, that just remains open. So it would be good practice for the quiz to get through that. You've got 3 attempts.